Hi everyone, in today's video we're going to talk about abstraction within the Java programming language. Like encapsulation, inheritance, and polymorphism, abstraction is one of the key programming concepts of object-oriented programming design. And when I talk about abstraction, that fourth one there, usually I like to say it's important to know the previous three because to fully understand what you can get out of abstraction, you really want to understand why it's important to encapsulate your data members and hide access to information in your classes. You want to understand why you would use inheritance to get some commonality in your code. And you want to understand the concept of polymorphism and having many forms of accessing your code. All of those really kind of culminate in overall code abstraction. So at a high level, how do we define abstraction? Basically, you can think of it as abstracting away the details of your implementation in your software to high-level interfaces or abstract classes that allow an API, an application programming interface, to access your data without needing to know the details of how you implement your code. Clear as mud, right? So what really is abstraction? Well, think of it as you're hiding away the details of the implementation. So encapsulation is hiding away the details of the class, the data members, and abstraction is hiding away implementation. That's kind of a way you can think of the difference. In today's video, I want to demonstrate using both abstract classes and interfaces, and then I'm going to briefly talk about the difference, though the full scope of differences probably would take too long to explain in a single video. I'll get into some code here so I can stop babbling on and we can get to the real good stuff. All right, in IntelliJ, I'm going to go ahead and make a project called Abstraction. All right, so what we're going to do to start off is we're going to go ahead and we're going to create a few classes that use inheritance. So I'm going to go ahead, go new Java class. We're going to create an animal class. I'm going to go new Java class. We're going to make a cat class. Then I'm going to go new Java class. We're going to make a dog class. Now, if you want a reminder on how to use inheritance, you can check out one of my previous videos. But otherwise, we're just going to go ahead quickly and have dog extend animal, and we're going to have cat extend animal. Now, in my animal class, I want to make a few methods that cat and dog are going to use. So let's say the animal can move, and let's say the animal can eat. Now, if I instantiate a cat or a dog, it should have that move and eat method. So let's say I do cat equals new cat, dog equals new dog. Just a quick reminder on what this is. This is creating new cat and new dog objects. This is what we call instantiation. When we get into what an abstract class is, we'll see that instantiation of abstract classes doesn't work. All right, so now if I do cat.move and dog.eat, that's good, but I need implementations in here. Let's just say moving, and let's say eating. Now if I run this code, I get what I expect, moving and eating. Cool. Okay, but I want it to be a little more interesting than that, so now I want to use polymorphism and I want to override implementations of some of these methods. So in my cat class, I'm going to go ahead and override the move method, and I'm going to say pouncing because cats pounce. And in the dog class, I'm going to override the eat method, and I'm going to say chomp chomp. And then as expected, we get the pouncing because it is our cat that is moving, and then we get chomp chomp because it is our dog that's eating. Great. Now, one thing I don't really like about this code is I can create an animal, and when I use the methods of animal, if I run this code, I get these kind of generic eating and moving statements here at the bottom, which isn't really that good because this default implementation isn't very meaningful. If I want to get around that, I can use abstraction. So we talked about how when you instantiate a class here, you create a new instance of it, and then that's called instantiation. So now what I'm going to do is I'm going to demonstrate abstraction. So there's a keyword called abstract. When I do that, now this little warning here, actually this error in fact, says animal is abstract, cannot be instantiated. Okay, so what does that mean? So fundamentally, abstraction within Java means that you cannot instantiate a type of that class. Okay, well, why in the world would you want to do that? Well, there are a few reasons you might. Let's say that you don't like these default eat and move implementations and you don't like being able to instantiate an animal. What you can do is you can force all subclasses to implement their own versions of the eat and move methods. And how you do that is with abstraction. So I made a public abstract class here. That's all you have to do in order to make an abstract class. Let's say I remove that here for a second. And now my code compiles again. But now I want to force all my subclasses to implement the move method. I can do that by adding the abstract keyword into my method. If I hover over this, it says abstract method in non-abstract class. So what that means is as soon as you make an abstract method, your entire class has to be abstract. And that makes sense because if you want all of your subclasses to implement a particular method and you are telling them that they have to do that, then you can no longer instantiate the base implementation. So now the entire base implementation needs to be called abstract. So that's the reason that has to happen. Now if I hover over here, it says abstract methods cannot have a body. And that's because you can't give a default implementation to an abstract method. So I'm gonna go ahead and delete this and just end it with a semicolon. Now if I look at my main.java, it's showing that I can't instantiate my animal, so that's good. So I'm gonna go ahead and delete that. And if I go to my animal, everything looks fine. If I go to the cat, everything looks fine. But now my dog is showing an error, and that is class dog must either be abstract or you need to implement the abstract methods within animal. So I want to instantiate dog, so I don't want to make it abstract, which means I have to implement the move method from animal. So if I click on this right here, and I'll go ahead and click OK. Now, how does a dog move? Let's go ahead and say running outside. Okay. Now what I can do is I can do dog.move. We'll verify that this works. All right, now that works, I'm gonna go ahead and do the same thing for the eat method. I'm gonna make this abstract, which means I need to delete the implementation, add a semicolon, and now if I go to the cat method, I need to override the eat method within cat. All right, so now how does a cat eat? We'll do crunchy crunch. And let's go ahead and call cat.eat. And dog.eat. Make sure everything looks good. All right, very good. So now that we have demonstrated abstract classes, let's go ahead and extend it a little bit further with some polymorphism. So if I change these to be animals, and I use the implementation specifically here, I can change this name with refactor, rename. I'll go ahead and call it animal. And I'm gonna go ahead and delete dog for a second. We can see that this still works. And we can see that this is the cat implementation. Now let's say instead of the cat implementation, I want to use the dog implementation. All right, now that we changed only 3 characters, we completely changed the implementation of our code. You can decide where you want to make particular implementation details in one spot in your code, and then in the other spot of your code, you can actually use the common methods and interfaces that you implemented over here in a single spot. That is the beauty of abstraction. All right, so now that we've spent some time talking about abstract classes, let's briefly talk about interfaces. Instead of calling this an abstract class, let's go ahead and call this an interface now. You'll see a few different things changed. So a few of the big differences are you don't need to use public abstract when defining these interface methods because that is implied. We'll talk about why here in just a second. And now it's also saying I have 2 related problems. So if I go here, If I hover over this, it says no interface expected here. The reason is because I don't use the extends keyword when I'm talking about an interface, I use the implements keyword. And then likewise, I'm gonna go ahead and use the implements keyword here as well. Now if I rerun my code, and just like that, we have the same result. Woohoo! Now, you might be asking yourself, okay, why are there two ways to do the same thing? We just made an abstract class and we convert it to an interface and they seem to be doing the same thing. Well, in this particular case, yes, they're doing very similar things, but generally speaking, an interface and an abstract class are pretty different fundamentally as far as what they mean within object-oriented programming. So the first thing you can think of is that an interface you can think of as a contract, and that is anyone who implements my interface needs to do these things. Whereas with an abstract class, that's not necessarily the case. All that an abstract class is saying is you can't instantiate it. You can force other subclasses to implement particular portions of the abstract class, but you don't have to. So the other thing that comes with that is when you think of an interface, it has to implement certain functionality. But one of the problems with not defining the details there is that you can't have state within an interface, whereas you can within an abstract class, because literally all you have to do to make an abstract class is you add the abstract keyword and then now it's abstract. So you can have state in your abstract class if you want, but you can't do that in an interface. So long story short, there are certain use cases for an interface versus an abstract class, and in a future video I can go through those differences and why you would want to use one or the other. So one other key difference between an abstract class and an interface is that in an abstract class you can only extend one, whereas an interface you can implement as many as you want. So in context, an abstract class can have all the state that it wants, and it doesn't have to force a subclass to do any particular implementation details unless there are abstract methods within it. Whereas an interface enforces that you have to implement methods per the contract. But you can implement as many interfaces as you want, and you can only extend one abstract class, so decisions, right? In a future video, I can go into a little more reason of why that's the case. In a nutshell, the language designers of Java wanted to avoid some of the pitfalls that come with multiple inheritance with a language like C++. Now, for the C++ people out there, multiple inheritance definitely can be useful, but as you know, it also does have issues that you can more or less get around with the single abstract class versus implementing multiple interfaces design philosophy that the Java language designers came up with. And that's abstraction at a high level. Abstraction I think of as kind of the culmination of the proper design principles of object-oriented programming, where you need to understand why you would encapsulate your code in order to use abstraction. And to demonstrate abstraction, usually you want to have inheritance and polymorphism in the mix because it's important to look at the differences between an abstract class and an interface. If you found this video helpful, please do smash that like button. I'd really appreciate it. In future videos, I'll go into more lower level details of some of the differences between abstract classes and interfaces, as well as some of the edge cases around how you would use them in certain situations. Thanks again for watching. I hope you have a great rest of your day and hope to see you next time. Take care.